Good morning, everyone.
Good morning, sir.
We're now dealing with powers of tan and cots. Okay. So specifically, I'm dealing with powers of cots. Yeah. So now, number one, integrating cots. This is, you will find this on the formula sheet. It's a standard integral. So the answer here is just that. Well, remember, before we start with this, k and b are numbers. They represent numbers. Okay, so k and b represent numbers there. So if there was an x here, it will be something completely different. If I had an x here, it's something called integration by parts, which is we're coming to, that's the end of this chapter. Right, so here you will find this directly, straight on the formula sheet. So when you integrate a cot, it's going to be ln of absolute value of sine bx, all divided by b plus. Now you might be wondering, where did the ln come from? So let me just show it to you. So if we go back to a basic example, let's take just cotx. So if I want to integrate cot, okay, let's just do it as it is here. Let's go for cot of bx. Okay. So now, from our identities, we know that there's two ways to write down cot. It's 1 over 10, and then also the other way to rewrite this as a fraction. If you remember from chapter 2, I think, where you were asked to use the quotient rule to differentiate cot, then you had to rewrite cot as cos over sine. So here, this is going to be cos all over sine. So now what do you notice? This is the type division. So where you have k f prime x all divided by f of x. Remember, there's a multiplication type and this is the division. So if the numerator is an exact derivative of the denominator, then the answer is always going to be ln absolute value of the denominator plus c. So let's check. This is a fraction, we check the denominator. So this is sine bx. The numerator, what is the exact derivative of sine bx? Let's write it down. I got my sine bx, cos bx. This is what I have originally, is just a 1 there. Can you see that? Originally, well, there's no number here, so it's obviously a 1. But what is the exact derivative of sine? It's going to be cos bx times what? Times b. So if I put it here or there, it doesn't really make a difference. It's supposed to be a b there. Can you see that? So now, we know that there was no b, it was just a 1. So if I write down a b there, I multiply by 1 over b, because b and b will cancel there, you can see that. So now, what happened? I created the situation where you have k, which is your constant there, f prime x, which is b cos bx, f of x, sine. The main thing is the numerator is a derivative of the denominator. So the answer will be, well, I put a k here, let's put a k here too. So you want to see it exactly like that. So let's put a k there. So that's going to be k times 1 over b, whatever number is in front there. So now that's going to be k times 1, which is k over b. We got f prime x over f of x. The answer is always ln of the denominator. Let's see. So you're wondering, where did this come from? It comes from the type division, exact derivative. So you can say that. Now you don't have to go and do it this way. You got the formula sheet. One time, you just write down your answer. So if I give you an example, let me go for 3 times the integral of cot 4x. Straightforward, all you need to do is check what is your b value. There is 4. When you integrate cot, that's going to be ln of the denominator, ln of sine, I'm writing bx there, which is 4x. So you know that if it's cot bx, it's going to be ln sine bx. So that's ln sine 4x, all divided by b, which is 4 plus c. And that is straight standard integral. This is explaining to you how they get that answer. Right, so you can copy it down in a few seconds. This is an easy one to copy down. Let's have a look at cot². Right, so this is not a standard integral. Now remember, okay, before we go back, so here I showed you why you get ln of sine bx. Right, so I mean there's a j. Now remember, you can check your answer. And how do you check your answer? Remember here, there's a formula here now. You know from differentiation, if y is equal to k ln f of x, the derivative is k f prime x all over f of x. That is your formula for differentiation. So if I take this, and if I state y is equal to k over b ln of sine bx plus c, and if I want to differentiate it, dy over dx, so the derivative here, well, this has to be numbers, so that's k over b, and then you got ln f of x. The formula is f prime x. So what is the derivative of sine bx? Cos bx times the derivative of bx, which is b, so that's f prime x over f of x, which is sine bx, and plus the derivative of any number alone, 0. So what happens here now? Your b and b here cancel. Can you see that? So therefore you just end up with k and then cos over sine, which is cot. So you get back to what it was. You cannot go wrong if you know your differentiation properly. Right, you can always check your solution. Right, so that's checking from using differentiation. Let's get back to cot² now. So this is cot². Now it doesn't really matter when you're dealing with tan and cot, whether you have cot² or cot to the power 3. We are going to be using our square identity all the time here. Okay, when you had sine to the power 3, then you use your square identity. When you had sine to the power 2, you use your double angle. Right, so that's different. Here, it's easier. So what is the square identity that involves cot²? Let's write that down. It's given to you on your formula sheet if you forget it. So your square identity here is 1 plus cot² of bx, whatever it is equal to 1 plus cot² is equal to cosec² bx. Alright, the one that you're familiar with, everybody is familiar with, is sine² bx plus cos² bx is equal to 1. That's the one you're familiar with, right, from grade 12. So I think in grade 12 you don't deal with cot and cosec, but now you do. You know that. So let me just show you how you get from here to there quickly. It only takes a few seconds. So now, what is this here? This is cot. What do you know? What can cot be written as? We know that cot is cos over sine. Right. So if I got cot², it's going to be cos² over sine². So there's cos². So what do I want? I want cot². So if I divide this by sine², that means I must divide every single term by sine². Whatever I do on the left hand side, I must do on the right hand side. 1 over sine². Now you can see that sine² over sine² is 1, and cos² over sine² is cot². And you know 1 over sine is cosec, so 1 over sine² is cosec². So that's just explaining to you how you get this here. You get it from sine² plus cos² is equal to 1. Now what's important here is that this cot², what do you differentiate that gives you cot²? Nothing. Right, if you think of all your derivatives, you differentiate tan, you get sec². You differentiate cot, you get negative cosec squared. Right, but there's nothing that gives you cot squared. So that's the reason why we rearrange this here. Okay, so cot squared can be written as cosec squared minus 1. Why do we change it to cosec squared minus 1? Because we know, if I ask you, what did you differentiate that gave you cosec squared? You know it. Okay, so let's write it down here. So, cot squared, you change it to cosec squared bx minus 1. Now, the question I'm asking you, the question you ask yourself when you're dealing with a problem like this, is what did you differentiate that will give you cosec squared? Okay, so now remember from your differentiation, if y is equal to k cot of f of x. Remember this? What is the exact derivative of cot? The derivative of cot is going to be negative cosec squared f of x times the derivative of f of x, which is f prime x. This you have to have in your head. Don't rely on the formula sheets, you know that. So now you got cosec squared. So if I ask you to integrate negative cosec squared, the answer is cot. You see? But now this is not negative cosec squared. This is positive cosec squared. So the sign will be the opposite, obviously. So now that's going to be k. Integrate cosec squared, it's going to be minus now. Because when you integrate minus, it became a plus. So when you integrate a plus, it will be the minus. You can always check it out. It will be minus cot bx all divided by b. And then obviously this is 1. Integrating 1 means, what did you differentiate that gave you 1? It was x. Plus c, and you're done. That's how we deal with cot squares. You can remove the brackets if you want to. It's unnecessary. Right, so let's copy this down and we can deal with cot to the power 3. Right, so we deal with cot to the power 3. Now, there are 2 methods. You can see I got method 1, method 2. The first 2 steps will be the same. Okay, for both this, so I'm going to do both problems at the same time. And then you're going to see where things start changing. Okay, or the technique changes. So now we got an odd power. What do we do? What did we do with sine to the power 3, cos to the power 3? If you have an odd power, split the odd power. So this is going to be equal to k times the integral of cot bx times cot squared bx. Right, whether it's method number 1 or method number 2, if you have an odd power, you have to split the odd power. Second step, this is step number 1. Second step will be the same. So what did we do here? We split the odd power. And the next step will be, you got cot squared, so we're going to be using our square identity. That is the next step. So your square identity, you know that 1 plus cot squared is equal to cosec squared. So we have cot squared there. I need to make cot squared the subject of the formula. So cot squared is equal to cosec squared minus 1. So let's do it here. So this is equal to k. I got my cot bx. And then I replace cot squared with cosec squared minus 1. Okay, so that will be a standard replacement there. So I'm replacing cot bx with cosec squared minus 1. Now, here is where things change now. Okay, from here onwards. So, method number 1 now. What we're going to do is, we're going to separate this into two different problems. I'm going to remove the brackets here completely. So what do I mean? I'm going to multiply k cot times cosec squared, and then k cot times minus 1. I'm removing the brackets. So let's see what happens now. So I got k times the integral of cot bx multiplied by cosec squared bx dx. Don't forget with the integration and your dx one time, separating it completely. And then k cot bx times minus 1 is minus the integral of k cot bx dx. Let me write down the k in front. Right, so this one we know, this is standard. This is number 1 that we just worked out. Integrating cot. This is not the problem. Term 1 is the problem. Can you see that? So term 1 involves multiplication. So if it involves multiplication, then first thing that comes to your mind is check, is one factor a derivative of the other factor? When you see multiplication, when you see division, you're always checking for exact derivatives. That's why you must have everything in your head for your table of derivatives, you know that. So, what is the derivative of cot? Negative cosec squared, you know, this is an exact derivative. It's only the negative that's missing there and the b. Can you see that? So what am I talking about? I'm talking about this type. When we first did it, this is type multiplication where you have f of x all raised to the power n multiplied by f prime x. So there's my f of x to the power 1 multiplied by f prime x there. And if this is the situation, then the answer will always be f of x to the power n plus 1 over n plus 1 plus c. And remember that there's a condition, your power must not be minus 1. Is your power minus 1? No. Your power, you can't see it, it's a positive 1. Can you see that? So this is the option integration by inspection, where you just do it in one step. The other option will be using U substitution. Right, so U substitution, maybe I'm going to do let me do the inspection here, and I'll do the U substitution there. Right, so if I want to do, I'm just talking about term 1 now. So let me show you by inspection. So what do I have? I have k times the integral of cot bx times cosec squared bx dx. Right, so now there's a check. All I'm doing is transferring this here just to show you inspection. So what is the exact derivative? You've got f of x, which is cot. What is the exact derivative of cot? It is going to be negative, so the negative is missing, negative 1 here. So it's negative cosec squared bx times what? B. Times b. So what's missing here is basically minus b. Alright, you can see it. There's the minus, there's the b, minus 1 times b is minus b. You can see that? So minus b would make it an exact, 100% exact derivative. But you know that there is no minus b here. So if I go and write down a minus b there, that means I need to divide by minus b here to cancel the minus b, because minus b divided by minus b must give you positive 1, always. Okay. So now I have the situation, constant f of x to the power n multiplied by f prime x. So there is this whole part here is f prime, this is f. Okay, you know your differentiation, there's no way you can go wrong here. There's your f, well it's actually f to the power 1 there, you can see that. There's your f prime. So now by inspection you go straight to your solution, and the answer is your constant, which is minus k over b, times f of x to the power n plus 1. So that's going to be cot bx to the power 1 plus 1, which is 2 over 2, and you're done. plus C. That is inspection. Obviously, 2 times B here is 2B. Alright, so that is inspection. But now let's do the U substitution. It's a safer option. You can't go wrong with U substitution. Here you can. If you're not sure about what you're doing, then you can make a mistake here. Alright, so but here, now by by U substitution, what am I going to do? I would say let's keep this one side here. So I'll go let U equal to. What will I let U equal to? Always let U equal to F, which is cot, and then du over dx. The derivative, exact derivative of cot is going to be negative cosec squared bx times the derivative of bx, which is b. There you can see there's the negative here, there's the b there, you can see that was the exact derivative. Make dx the subject of the formula. So dx is going to equal to du divided by minus b cosec squared dx. The only time you will get this wrong is if you don't know your differentiation. Okay. So now we take that, transfer it here, we substitute, so that's my k there. I got cot, but cot is no more cot now. Cot is u. So that's going to be u times cosec squared times dx. But dx is no more dx. Dx is now replaced with du divided by minus b cosec squared bx. Now you can see the exact derivative always cancels. That and that cancel. So remember, you got 1 on the top, divide by minus b. So I told you, take your fraction, multiply it by the fraction in front, always. So that's going to be k over negative b. Right. And then I got the integral of just u to the power 1 du. That's what happens now. Because cosec squared and cosec squared cancelled. Now we can integrate with respect to u, so that's going to be minus k over b there, times, now I'm integrating with respect to u. The last part is the easy part, just to integrate, no? So 1 plus 1 will give me 2 over 2 there, and I can substitute back, so that's my k over b, u squared over 2. What was u? U was cot. Check it. There's a check, and there's a check. This is by inspection, this is by u substitution. You must come to the same thing no matter what. So that don't forget, so we also got this one to do. This one is in one step. It's a standard integral. So let me just go here. So this is going to be minus k integrate cot. That's going to be ln of sine bx all over b plus c. And you're done. Alright, now before you copy that down, let me do the second method. Right, so what? You know what happened here. It was all about separating it and exact derivative. You can say that. Now, the second method. So where did we stop with the first method? We stopped at this point here. So, up till this stage here, you will always split your odd power, always use your square identity. But now, what happens, because you notice when we're dealing with cos to the power 3, when we came to a situation like this, remember I told you don't have to remove your brackets. Okay. So, what happens if you do not remove your brackets here? What happens if you let u equal? Because you notice now, this is what happens. You always remember that something to the power n, and whatever is the base, you always let it equal to u, most of the time. So the question is, what will happen now? So let's see. If I let u equal to cosec, then du over dx. What is the derivative of cosec? You must know your differentiation. What is the derivative of cosec? The derivative is going to be negative or minus cosec bx. Sorry, let me just write cot first. Oh, let's write it down here. The formula first, okay, properly. If you have y is equal to k cosec f of x. Alright, let's do it like how we did it in chapter 2 or chapter 1. So my dy over dx here, the derivative of cosec is going to be negative cosec f of x times cot f of x times f prime x. That is the formula that you have to know. Okay, do not rely on the formula sheets. So here, if I want to differentiate cosec, so then du over dx, the derivative of cosec, here's it here, it's going to be negative cosec times cot times the derivative of bx is b. Alright, so let's not confuse this here, this is just the formula. Right, so there's a formula to differentiate that. Now, make dx the subject of the formula. So therefore, dx is going to equal to du divided by minus cosec bx cot bx. Now, what do you notice? Du divided by negative cosec bx cot bx. But what was our substitution? That cosec is u. Remember, cosec is u. So I also have cosec here. That means wherever I see cosec, I need to replace it with u. Now we have our dx. Let's do other substitution. So this method is, you do step 1, split the odd power. Step 2, use your square identity. Step 3, let you equal cosec. Now let's see what happens. And that's going to be k. Here I got cot bx. And now I got cosec squared. Remember, cosec is u. So this is cosec squared. So that will be u squared minus 1. And dx, there's my dx now. Can you see the dx? There's a dx here, which is du divided by minus u times cot bx. What happens? Cot and cot will cancel only. So let's see what remains. So now I got my fraction here. This is a negative 1. Okay. What did I forget over here now? I forgot something.
The b.
I forgot the b. I just realized. I can see now. I forgot the b. So that there's the b here when I manipulate it. There's the b here. So that's minus b there. So that's going to be minus b there and minus b there. Alright. So cot and cot will cancel there. So what happens is you end up with minus k over b. Those are the constants and the variables now. On the top, what do I have in the numerator? The numerator has u squared minus 1. But the denominator, what does the denominator have? Don't forget you got the u here. Can you see that? There's the u. So now this is reduced to like an N4 type simplification problem, where we have to simplify first, integrate second. So now I can separate this into two fractions, two different terms basically. And that's going to be u squared over u minus 1 over u. I'm separating them because we cannot integrate. This is not in any standard form that we can integrate. So that's going to be minus k over b, and then u squared divided by u. Exponent laws, when you are dividing and the bases are the same, write down the base 1, subtract 2 minus 1 is 1. So that's u to the power 1. 1 over u, you know, you leave it as 1 over u. And now, finally, we can integrate with respect to u. So that's my minus k over b. Integrate u to the power 1. That's going to be 1 plus 1, which is 2 over 2. Integrate 1 over u, which is going to be ln absolute value of the denominator, plus c. And you're done now. Substitute back for u. That's my minus k over b. That's my 1 over 2 u squared minus ln of u plus c. What was u? U was cosec. So that is cosec dx, and this is cosec dx also. So it's not, you will notice that what matters at the moment is only this term here. You got the minus k over b times there, you're going to get ln, and you can see that. Okay, that's going to be k over b ln. Now you might wonder, the term 1 doesn't match. If you use your square identity, 1 plus cot², and change it, then you should get back. These two answers will be the same, except you'll have an extra constant. Right, so that was method number 2. I'm going to deal with an example now.